Don't forget to subscribe and share. Thank you.
All right, we are back again, and I'm always happy to see you back again learning with me here. So now we have y is equal to the secant inverse of x. So now we look at the inverse secant function. So now we've looked at four of the functions: sine inverse, cos inverse, tangent inverse, and cotangent inverse. And we saw that, okay, sine and cos are just negative of one of them, and then tangent and cotangent is one negative of one of them. Now let's look at secant and also cosecant, what we can do here. Now when I differentiate secant inverse, here dy over dx is equal to d over dx. Now here is secant inverse of x, and when I differentiate this, what am I going to get here? This is 1 divided by x square root of x squared minus 1. Beautiful. So you see, this was looking like the sine function, or let me say that, yeah, but this is not true because the sine was 1 divided by square root of 1 minus x squared, and there was no even x here. So you need to pay more attention also here. So this is what we are going to get for secant inverse. So let me just write it here, and we move to how to prove that. So secant inverse of x, this is equal to 1 divided by x square root of x squared minus 1. So let's try and prove this here. Okay. Now we have this, so we can take this and then have secant of y, which is equal to x. So from this one, we can write this one like this. Differentiate both sides with respect to x. So we differentiate both sides with respect to x, which is equal to this. Beautiful. Now, when I differentiate secant, what am I going to get? Very, very important here. So when I differentiate secant, we are going to get secant tangent. So that's what you need to remember here. So secant tangent. Secant of y, tangent of y times dy over dx. So don't forget, when I differentiate, I need to differentiate what is inside using the chain rule. And when I differentiate s, I get 1. So now let's find dy over dx by dividing through by secant y and tangent of y. Now let's look at what is here. We can see that our function is in terms of secant already. So we don't have trouble with this because we know that we can replace secant of y by x here. But the only problem here is the tangent of y. So we need to go and look for the trig identity, or let me say trig identity, which involve tangent. And we know that 1 plus tangent squared of y is equal to secant squared of y. Great. So now we can just try to make this one the subject to make sure that we don't have tangent inside our function here or formula here. So if I want to make tangent the subject, then tan squared of y is equal to secant squared of y minus 1. Then I need tangent of y, not tangent squared of y. So I can take the square root on both sides, and I'm going to have tangent of y is equal to square root of, I can write this secant squared as secant y all squared. So I can have secant y all squared minus 1. So I'm going to replace this one by this. So I'm going to have 1 divided by secant y square root of secant y all squared minus 1. But what is secant of y? Secant of y is x, which is here. So we can just do that replacement and have 1 divided by x square root of x squared minus 1. And you can see that this is what we have here. Beautiful. So that is how we can prove that, right? Great. Now going through the proofs help us to remember that, okay, this is accurate. This is the right formula here. So what will be the general formula, right? How to find the general one here. So it's the same thing, d over dx secant inverse of u. This is going to give us 1 divided by u square root of u squared minus 1 times u prime. So the general one is just multiplying it by u prime, and then you are done. Most of the cases we put absolute on this, most of the cases, because we are looking at if this is minus, then we want to make sure that this turn out to be positive. So most of the formulas, they use absolute here, what is also right? You can just put the absolute there, and then you are done. Now let's practice with 5 examples of 4, and I'll give you a trial question to do. If this is your first time here, we have some previous video. You can go to the playlist, or you can go to the course and look for math, or let me say further calculus, and you can look at the playlist, and you can enjoy how we started the procedure. I will leave the link also in the description, that you can click on it and you can start the course and you can learn along with us. Don't forget to subscribe if you haven't done that. Like it, and I'll give you a trial question too at the end of this practice examples, and then you also try your hands on it to leave your answer in the comment section. I enjoy those who are leaving the answer in the comment section. It helps me to engage with you guys. So let's keep it up. Now let's look at this one quick. So we want to differentiate this x squared secant inverse of x. So product rule again, right? So I love product rule. So let's pick a to be x squared. Let's pick b to be secant inverse of x. What is a prime? Using the power rule, this is going to give us this. And then what is b prime? This is what we just learned. So this is 1 divided by x square root of 1, x squared minus 1. So here you need to pay attention when you are writing it, because it's kind of like similar to the sign. So that's what you are going to get. So when I take the derivative of this, because I know how to differentiate individual function x squared and sine and secant inverse, and I know how to use the product rule, you see my life has become so easy, and I just can do this: a b prime plus b a prime. So this is what I'm going to get. So what is a? A is x squared times what is b? 1 over x square root of x squared minus 1. I love writing parentheses because of negative. I don't want to do mistakes. And then b is secant inverse of x times a prime is 2x. So this is going to give us, one of the x can cancel one of the x here. So when I multiply it, I have x divided by square root of x squared minus 1, plus I can write the 2x first, and then have this here. Very simple. So I know product rule. I know how to differentiate these individual functions or specific functions. So I don't have issue with this. Then I take derivative with confidence. I'm smiling and I'm doing maths. That is beautiful, right? So you need to enjoy, doing mathematics, because as soon as you understand the basics, you are good to go, right? You enjoy doing mathematics that people say that it's difficult. It's difficult. It is not difficult. It is not difficult. Not at all. It's just like you need to practice, Yeah. So let's look at this one too. We want to differentiate this. So what are we going to get here? And when I differentiate secant, what am I going to get? Okay. Secant is going to give us secant x tangent x. Beautiful. But now we need to focus on this using the general rule. So d over x secant inverse of u is equal to 1 divided by u square root of u squared minus 1 times u prime. My handwriting is getting small. U square root of u squared minus 1 times u prime. So let's figure out u prime here. Let's figure out u here. U is 5x. So u is 5x. U prime will give us 5. Nice. So now what can we do here? Okay, this is going to be minus 1 divided by u is 5x, so we have 5x square root of u squared. So this is going to be 5x all squared minus 1 times u prime, which is 5. This is beautiful, right? We can simplify. 5 can cancel this 5 here, and we have secant x tangent x minus 1 divided by x square root of, this is the same as 25 x squared minus 1 if I want to expand this one here. So you see, it's not difficult, right? It's not difficult. It's very simple. Yes. Let's do this together. Let's look at question 3. Let's differentiate. So y is x squared sine inverse of x plus, now the square root here, I can write it as secant inverse of 2x or to the power 1 over 2. Okay. Now, I just brought in one of the functions that we did. So remember when we differentiate secant inverse, right? So the first term here is product rule. So let's work with the first term, right? So let me assume that this first term here is f and this second term here is g, right? So I'll have y prime to be equal to, or let me say dy over dx to be equal to f prime plus g prime, right? So if I want to differentiate, I'm saying that this is equal to f, right? So f prime, and this is g, so it's plus here, so plus g prime. So since we have this one, we can now go and figure out and come and bring them to. So now f is equal to x squared sine inverse of x. So we need f prime using the product rule. So this is AB. Now my A is equal to x squared. A prime will be equal to 2x, right? Great. And my B is equal to sine inverse of x. So my B prime, remember that this is sine inverse. So remember the formula, 1 divided by square root of 1 minus x squared. Great. You said it right. So now let's look at f prime using the product rule. So product rule, a times b prime, and then b times a prime. So this is going to give us x squared in parentheses, 1 divided by square root of 1 minus x squared, plus sine inverse of x times 2x. So we can simplify this and have x squared divided by square root of 1 minus x squared plus 2x sine inverse of x. So we are done with f prime, so we can substitute this one here. We need g prime. But what is g? G is equal to what is here. So let's figure out g2. So g of x, or let me say g is equal to secant inverse of 2x all to the power 1 over 2. So here we need to use the power rule, like kind of change rule. So we need to use the power rule first. So g prime is equal to 1 over 2 drops down. We maintain everything in the parentheses. We don't touch it. Then we subtract 1 from half, which is going to give us minus 1 over 2. Now we multiply it by taking derivative of what is inside the parentheses, which is the secant inverse of 2x. Now we need to figure out this guy. Okay, what is this guy? Now, using the idea of this, we know that this of secant inverse of u is equal to 1 divided by u square root of u squared minus 1 times u prime. So u is equal to 2x and u prime will be equal to 2. So it means that when we want to simplify this, this is the same as 1 over 2 secant 2x to the power minus 1 over 2 times, this is 1 divided by u is 2x, then square root of u squared minus 1 times u prime is 2. So this 2 here can cancel this 2 here. We can write this one as 1 over 2 secant inverse of 2x minus 1 over 2. And this is times 1 divided by, no, the 2 will cancel out. So x, 4x squared minus 1. So when I expand this one, I have this. So we have g prime, we have f prime. So what can we do? Let's just put them in there. So let me bring another sheet with the same question again. So we know that y prime, or let me say the y over the x, is equal to f prime plus g prime, right? Because this was our f and this was our g. So what is f prime? Okay, f prime is this guy here. So because I want to, let me copy this and just come and paste it here. Beautiful. So let me just have this one dy over the x here, which is equal to f prime now plus g prime. Plus g prime. What is g prime? Okay, g prime is what is here. So let me also copy this one and just go and paste it there. Have it this one here, paste it. Oops, I think I can bring this one in small so that I can have it go here. Okay, let me just shift this guy small so that we can have this one right. Great. So now this is our f prime and this is our g prime, and this will be the final solution that we are going to get here. You can decide to simplify. Okay, this one we can simplify again, but you can decide to simplify this if you want to. If you want to, this is going to give us plus 1 over 2 times 1 over secant inverse of 2x to the power 1 over 2 times 1 divided by x square root of 4x squared minus 1. And you can also say that this is the same as, so I'll multiply all the denominator together. So the top is 1, 1, 1. So the top will be just 1. Then when I multiply 2x to this, 2 times 2x is going to give us 2x times the square root is going to give us square root of 4x squared minus 1. Then times this guy here. And I have secant inverse of 2x to the power 1 over 2. And I can even turn this one to square root again, right? So that is the idea. I can turn this guy here to square root. So sometimes it depends. If it is a multiple choice, it depends on what the options are giving you. If you are not having the answer, then it means that you need to go deep and simplify. Now let's do this one again. Let me write this one down here. Secant inverse of x is equal to 1 divided by u square root of 1 minus u squared minus 1 times u prime. So now if I want to find dy over dx, which is the same as d over dx, secant inverse of x plus 1 divided by x minus 1. Now when we compare it, our u is equal to x plus 1 divided by x minus 1. So we need u prime, and u prime we need to use the quotient rule. So quotient rule, since we have a over b, a is equal to x plus 1, a prime will be 1, b is equal to x minus 1, and b prime will be equal to 1. Nice. So quotient rule says that, so let me just move this one up and then I'll write u prime here. So quotient rule, maintain denominator, differentiate the top, minus. Now maintain, differentiate the denominator divided by b squared. So let's do substitution. B is x minus 1 times 1 minus a is x plus 1 times b prime is 1 divided by b squared. Let's simplify this. We are going to have x minus 1. Then when I multiply this one by 1, I get the same thing, multiply by minus, and I'm going to have minus x minus 1 divided by x minus 1 squared. So this will cancel this, so you will be left with minus 1 is minus 2x minus 1 all squared. So I have my u prime. So this, using the formula here, we are going to have it to be 1 divided by u, which is the whole of this. So I'm going to have, let me put it in parentheses, x plus 1 divided by x minus 1, then square root of, just shift this one to this side small, square root of u squared again, so x plus 1 divided by x minus 1, or squared minus 1, so we are just doing substitution here. Then u prime is this, minus 2 times minus 2 divided by x minus 1, or squared. So this is what we are going to get. We can decide to, simplify this and then now cancel some things out and that. So I think this is our last question before we get to the trial question. So let's try and then, simplify this. Let's play around this, right? So now, this is beautiful. Let's see what is going to happen here. Now I can multiply this to this and multiply this one to this one here. So let's do that. Let's play around this before we close this section here. So when I multiply this one by this, I want to bring it to the front. So I'm going to have x minus 1 squared times x plus 1 divided by x minus 1. Then square root of, this is the same as x plus 1 squared divided by x minus 1 squared minus 1. As we know that a over b all squared is the same as a squared b squared. That's what we use to expand this one here. Okay, let's go again. Now this, we can cancel one of this, right? Because this x minus 1 squared is the same as x minus 1 times x plus 1 x minus 1. So we can cancel one of this. So it will be left with just 1 from there. So this is the same as minus 2 divided by x minus 1 times x plus 1. Now, this one of them is cancelled, so it will be left with this and one of this. Then if you want to simplify this, this is going to be x plus 1 squared minus x minus 1 squared divided by x minus 1 or squared. So what did I do? This is divided by 1, so 1 times this is the same thing. And then this times this is minus of this. And then since this is divided by 1, this times this, given as this. Now we know that square root of a over b is the same as square root of a over square root of b, right? So we can take square root of just the top and square root of just the down here. Okay, so let's look at what is going to happen. Minus 2 divided by x minus 1, x plus 1, and then this is the same as square root of x plus 1, x minus 2, x plus 1 minus 2 to the power 2, then x minus 1 to the power 2, divided by, so now divided by square root of x minus 1 all squared, but the square will cancel this. So this is the same as, x minus 1. Good. And this guy will cancel this guy. So finally, we are going to have our solution to be minus 2 divided by x plus 1 square root of x plus 1 squared minus x minus 1 squared. Now we do this when the function is multiple choice and we don't find the answer there. We need to simplify to find the solution there, right? So that's basically for question 4. So now this is the trial question for us to try our hands on. Make sure when you are done, you leave your answer in the comment section. If your answer is so complicated for you to write it in the comment section, you can take a picture of your answer and post it in our YouTube community. You can post as much as all the questions in the, our videos, trial questions in our community for us to, like it and see if you are right or wrong. We are all learning. So if you get it wrong, we are learning, right? Yes. So that is the idea here. See you in the next video where we are going to talk about just the negative aspect of what we just learned. That is the cosecant inverse function.